I'm going to talk to you a little bit about the work of the committee, what we have done, what our goal is, the standard that we're working on. So, I'm sorry, I promise you it gets better. The rest of the presentations are very interesting things to show to you. But there's also some things that we have been looking at in terms of not only how do we develop the standards, but how we apply them and bring into practice and the advantage that you can get from it. So, a little bit of the roadmap. It's an overview of the committee, who we are, what we are working on, the published documents that we have out there to be readily usable, the ongoing documents, the development that we're working on right now in the committee, and finally a little bit more on the workflows and implementation that we work from Jordatech supporting the developments and the value considerations that we have seen from this process. So, ACI 131 committee, it's the building information modeling of concrete structures, and these two pictures have been there in a while because these are basically the guys who opened the committee and got us where we are. Pete Corrado and Alan Boomer, and most of the things that we have out there have major contributions from them. I think they're both retired now, so they're not recently retired both, but we have 17 voting members, 21 associate members, and 7 consulting, and our goal is precisely the name of the committee, right? Develop and report information on the application of building information modeling for concrete structure. So basically help or assist in the implementation and development of BIM around concrete. Now, the question is, why do we, you can already go to Revit and model a concrete structure, so that's BIM, right? You're done. But through this, and probably you all know, and that's the reason why you're here, it's more complex than that. We have a lot of tools, and if you live in a proprietary environment, call it Autodesk, call it Bentley, call it whatever you want. It's fine, but once you get out there with different tools, different exchanges, well, it gets more challenging. And as most of you know, Building Smart came out with an open standard, neutral way to talk between tools, between the stakeholders, IFC, Industry Foundation classes, which is an open standard to define and report that model and non-model related data and transfer it. I don't know if you have quote-unquote played or not with IFC, but it's quite broad. So that's what we need to define a little bit more, the things inside of IFC, and I'll get into that a little bit more in a minute. But where we are in the committee is steel and precast. Well, steel, they don't have major standards, but if you think about steel, steel is in itself pretty standard because a W shape is a W shape. And that's already standard. And that's the way you build it, and the piece comes. There might be some logistics interconnections and on the fabrication, but there's fabrication software for that. But in terms of how you understand what a W18 by something is and the way you understand it, that's fine. Precast already have their standards. The PCI already developed them, help from Jordatech and the Charles Franco Foundation. But if you think about precast, it's also parts that you put together and then join, right? So it's already broken into pieces. The problem with concrete is first the supply chain. It's a little bit more interesting because you not only have the typical stakeholders, then you talk about concrete, you talk about rebar, concrete, finish, temporary structures, formwork, scaffolding. So how do you coordinate all these people? How do you make all these people talk? And more challenging than that is the monolithic versus object-oriented nature of the model. If you think about steel, if you think about precast, a beam is a beam, a column is a column, and there are parts that you put together. In concrete, cast-in-place concrete, there are several views that you have. The physical model, which is, you would call that a frame, but then the detailer finishes an object here and starts the next there. But the structural says, no, actually there's no boundary, it's just a node. And then the contractor says, no, but I built it this way. So I split it here and I split it here. So now you're having different people looking at the same building differently, and they gotta be consistent. So cast in place is inherently a little bit more challenging than the other materials. For BIM purposes, for modeling purposes. So going back a little bit to that IFC side, IFC is a standard readily available. You can export it, you can import it in the tools you have. The problem is IFC is pretty flexible, and that's an advantage and a challenge. Because if I tell you Apple and you don't know what Apple is, you don't know how to process that. So I can tell you BIM, and a BIM has top and bottom reinforcement, but the program, unless it understands that I'm saying number 3 at 20, if you're not capable of reading that, it's a challenge. So you need to standardize that. So the national BIM standard proposed a path to try to further define what needs to be defined when you are looking at a specific industry. So the typical path is, first you look at the whole industry and you say, okay, how many people do you have? What do they do? What tasks do they perform? And how do they exchange data? What model goes to whom? From the architect to the structural to the detailer, and so on. Once you have that, you take every exchange and say, okay, what do you need from me? What do I need to give you? This is the data that we need, and this is the way we're going to express it. This is what I mean when I say top, middle, and bottom bar in a BIM. This is what I mean when I say this, when I say that. So that's a specific view of the model that we are exchanging. That's called a model view definition. And finally, we test it, we model it, we validate it. So that's what we have done, a little bit of what we are doing, and what we're testing. So we're kind of following this general guideline. So that's what the committee does. That's our goal. That's what we're after. So we have 3 published documents so far. The first one is the first one that I was talking about. It's called the IDM, the Information Delivery Manual, which is that roadmap that has the people, the stakeholders, the tasks, everything around it. So I'm not pretending for you to be able to read it, but that's our roadmap. That's our business process model. That's concrete. These are the stakeholders, the people involved, designer, architect, structural engineer, the tasks that they perform through the project lifespan. And then you have the tasks and all the data exchanges in between one stakeholder and the other. So that document is published. It's called ACI 131.1R. And it defines all this process. Now, the first exchange that was, and this is already a published document, I'll talk about it in a minute, is the reinforcement placement model. So this is the actual detailed rebar. How do you export it? What properties do you export? What you mean by the properties? So you can actually find it in a couple modeling tools to be able to export this exchange. And it was very important because rebar is kind of an important component of concrete. The other 2 exchanges, these are the ongoing developments, is the structural design model, which is the design intent from the structural engineer to the detailer or the contractor, and the construction reference model, which comes from the general contractor to the engineer, to the coordination, to the trade. So that's what we are working on. The next document that we published is that EM15, which is called ACI 131.2R, was in 2017, which is the first BIM data exchange for concrete industry. So we have the IDM, and then we took the first one, and that's published, and it deals with rebar. So if you look into the document, you'll see bar information about mark, size, geometry, surface, bar. So all the data that you might need to describe and specify rebar, that is actually 3D model. So this provides you a standard way of communicating it. So if you follow the standard on export and follow it on import, everyone's going to be able to read the data effectively. And beyond the bar, it deals with end preparations with welded wire reinforcement, couplers, terminators, accessories, callouts, pretty much everything there. So if you go to the document, you will see some images and you'll see all these specifications on kind of agreeing on what we mean when we say something about the rebar. So that's the first one that we have published, the first actual exchange along with the IDM. And finally, there's a recent tech note that tries to help us agree on what we mean by the level of development, meaning how detailed a model is when we talk about the model itself. It typically goes from 100 to 500 when you're designing, and then operations go beyond. But if I say LOD 400 for concrete, what do I mean for the concrete, for the rebar, for the formwork, for everything around? So that's the third document that is published, trying to make us agree on the language as well. So now that that's done, we have 2 more exchanges that we're actively working on. And one update to the EM15, the rebar. So for the rebar exchange, we've been working with the PTI, the Ostension Institute, to add the Ostension reinforcement to the exchange. The exchange didn't account for that when it was published. So we've been working on it. It's actually been, I think, fully validated for now. So it should be ready for discussion and publication soon to account for this very important component of custom structures as well. So more properties on or agreements on that specification. The 2 other ones, and I'm going to spend a little bit more time on these ones. The first one is the structural design. So the design intent coming from the structural engineer to the detailer to everyone around. So deals with the main concrete elements, but this is typically what you would see on a structural drawings or structural plans. Details, schedules, trying to specify the rebar sections, where bars are where, what you would see coming out of an engineering office to the detailer or to the contractor, right? The thing is, if you think about it, most firms right now would model in Revit, export it to 2D, send it to the detailer. Best case, you also export a spreadsheet, and then they have to re-import it and work from scratch. So why don't we just attach this in a standard way that we all agree on to our model and bring it along, right? So that's what this exchange is about, is taking all the main elements, beams, columns, walls, slabs, and defining what is the typical data that we transfer on the schedule, that we communicate. Typical, I mean it's concrete. You're always going to find an exception. But on what we can most agree on, how do you communicate that? So what do we mean by tie by zone, spacing, and how do we write it? How do we specify it so I can export it and import it, and look at further applications, and I'll show you a little bit about on the implementation side. So that's the first one that we're working on, getting input from structural engineers, from detailers, from contractors, trying to get a lot of agreement on this. The second one is the construction reference model, which comes out of the general contractor with information about the material and the sequencing and planning. So it has formwork, it has embeds, finishes, and you're able to coordinate and deal a little bit with it. So once again, what information do you need for pours, for scheduling? Challenging in this exchange is the fact that you need to group elements. You're not thinking about one beam, one column. You typically do pours, and those pours group objects. So how you deal with either a part of an object or a group of objects that you're going to pour together. So that's what we've been working on. Both documents, the EM6 and the EM20, are ready for scope balloting. So we have sort of an agreement or what we're trying to achieve here, and then we're going to start revising on the properties and the way we specify this to be able to bring into publishable documents that hopefully you can use in practice soon. So that's basically a little bit of the work of the committee, what we have done, what we are doing in terms of the BIM standards and the ongoing developments for coming out of the ACI. Now, the additional support that we've been trying to provide, and we try to provide from an academic standpoint, is how does this affect the way we or our practice, and how do we help implement it to show how you can be using this? So it started with an ethnographic study with a method of applied ethnography. We just took a design company and we sort of shadowed a project, a big hospital in near Atlanta in Georgia, and then we took a bunch of observations, field observations, interviews, and more importantly, process and exchange observations. So this is a company that already had BIM processes in place, but without the standards. So how is the data being communicated, being transferred? What is proprietary? What did you have to develop to be able to let these things talk? Because not all the companies have the infrastructure to build these exchanges in a proprietary manner. And from this, we did some coding on the data that we were gathering in terms of all these dimensions for two reasons. First, to be able to map the workflows, and second, to be able to understand the value that it could be providing to the practice, the way it worked. So in terms of the workflows, focusing a little bit in the interest of time on these two exchanges, the design intent, we were able to map it, and even within a BIM environment, it can get complicated in terms of moving here. You can start it on the structural realm on the BIM tool, or you can start it on the analysis tool, and then you move it across the different tools that you have. But then you still gotta export it, define a way to export it to your column design tool, to your beam design tool. If you have a slab or wall design that is probably developed in the office itself, and then you bring it back, and then you bring the data, and then you coordinate it. So even within a BIM environment, it can get a little bit challenging. It's better than 2D, of course, but it still gets a little challenging. So when you bring standards, the process becomes something like this. It doesn't matter anymore who's exporting and who's importing, because it's a standard. All the tools are going to understand what you mean when you export and when you import, because it's written in these standards. So we know what a column is, what the top reinforcement is, what the ties are, how to represent what you would typically do on a schedule. And once you get to that, then how do you implement it? So this is one of our test models. We took element models, then simple building models, then this medium-sized building, and finally we tested on the hospital that we were shadowing. So we added all these properties that were being developed, and then the immediate question is, as an engineer, as a detailer, as a contractor, yeah, I have the data, but then you're asking me to put it the way you want it. That's extra work for me, right? You're asking me to invest more time, either who's gonna pay me for that, or either am I responsible for that? Because there might be some things going on, right? So the truth is, this is very professional oriented in terms of these professionals providing the way you represent the data. So the conversion on the back end might look complicated, and it really isn't. It's just a matter of translating the way you typically have done it to the way the standard is proposing it, which is, you will see, or you can see, is very agreeable. So we develop all the mapping necessary to be able to develop a correspondence with these properties. And then once you have it, then you just have an IFC file that you can import anywhere, and it's going to hold those properties. That is in a neutral environment, open format, following a standard manner of communication. This is just a visualization tool to be able to see those properties. But at the end of the day, these and these are the same. The difference is, this you could parse if you follow the standard. This, either you start using AI, or you start using some things to read it, or you have, best case, a table that you can query data from and start mapping. This is already mapped, right? And what you could say from it is, for example, this. This was sort of, quote unquote, a round test because we brought it back to Revit, but you could bring it to ProConcrete or to any detailing tool that you want. If you have all that data, and you know what the data means, you can, for example, develop a non-detailed version of the Rebar. The detailer can then pick it up and start detailing from that, because you already know what you mean, right? Whereas on the top, then how much time is it taking for you to go through this process? Okay, so that's one of the implementation approaches and the value that you will get from one is using these standards in practice. The other one is the construction coordination. Same, we're mapping the process, the way it was working, the way they were interacting to coordinate this. And once you bring the standards, or you standardize the way you communicate data, it gets far simpler, because it's tool agnostic and it's process agnostic, because you agree on the task that you're trying to achieve and the language that you're using to deal with this exchange. So, similar approach, we embedded the properties, we developed codes to populate them. In this one, we had an additional challenge, which was, as I mentioned, dealing with the geometry. Parts of geometry representing it to be able to coordinate and visualize it. So that's what we have two different implementation strategies here. But at the end of the day, you can automate all this. It's just a matter of develop the automation necessary to do the translation, and then you're good. So when it comes to it, same thing. Instead of dealing with this, trying to represent the pools, group them, whatever your approach, however advanced it can be, at the end of the day, here, you already have it in the model that you already developed. And the contractor already has the data. So just put it in, and let's make it efficient. For example, for 3D visualization. You don't have to build it anymore, because you already have the sequencing, you already have the grouping, and you already have the properties. It's just a matter of agreeing what I mean when I say poor date, what I mean when I say poor object, poor group, and then you can actually use the standards to move forward. So this is just an overview of how these workflows start changing our process a little bit, making it far easier. And the question then became, what's the actual value? Because you can read 200 magazine articles, 300 papers about the advantages of BIM, and they're all right. But how do you actually account for the value or capture that value? So if you go to literature, you're going to find, and this is just the most famous ones for BIM, but you can see advantages in cost, in reduction on cost, on time, productivity, gains in productivity, reduction in RFIs, change orders, errors and omissions. So pick your poison. That's a general overview of what you could see in terms of the advantages of BIM. Now the question became, what is the advantage of using a standard in our BIM process? Because the advantages of BIM are understood, are clear. So that's what the ethnographic study that we started with allows us to do, because now we had the process, we had the new proposition on implementation methods, and then we had what it could look like. So we repeated the process with a couple more modelers and validated with practicing engineers and people from the industry. And at the end of the day, we came with where we found 5 dimensions that the standards actually, and they can be intuitive, but we needed to find a way to derive it from what we were working on. So the first one, implementation time, that's the quote-unquote cost that you would think, because then you need to be able to implement this either in practice or in software and then adapt to it. But that's a one-time thing. You do it once, you establish the mapping once, and then on every project or every time you use it, there's the information production time, which is undeniable, because then you're not, either you don't need to produce 2D schedules or 2D coordination plans. You're actually carrying the data on the 3D. You have reinforcement detailing time, because then you actually are receiving the data. And detailing is just because of the exchange that we're doing. You could look at this from the formwork perspective, from the scaffolding perspective, from the coordination of temporary structures perspective. All of it can be derived automatically from the model that you're working with. Construction coordination time. This is one of the most important that we couldn't measure it, because measuring errors and omissions first, surprise, surprise, a company doesn't like telling them what they're doing wrong, so we couldn't go there. But it's undeniable that if you are taking a 2D and trying to bring it on a detailing tool, either manually or parsing data and mapping it, you're prone to error. Whereas if it's carried by the tool itself from the moment you specify and design it, and is bringing the design intent from the engineer, the data is there. So you are way less prone to errors, emissions, and then you're improving your productivity in terms of detailing, coordination, and production. So that's pretty much what I had in terms of what the committee has done, what we're doing, and what we're trying to achieve in terms of how do we bring it to practice. We're always welcoming people who want to chip in on the way we're approaching the standard, the data that we're trying to communicate, because the more professionals that we have involved, the more capable are we of representing the data from different companies and stakeholders and so on. So